The world has decided that it is time to tackle climate change. Europe's goal is to reduce its CO2 emissions by 40% in 2030 and by 80% in 2050. Other countries have also set similar goals. To significantly reduce their CO2 emissions, Europe and the rest of the world must gradually improve the efficiency of their energy system and at the same time switch to more renewable energy. This film focuses on one of the biggest challenges that must be implemented if Europe and the rest of the world is to integrate more renewable energy and achieve its CO2 targets: the development of new, modern district heating systems. These local networks have delivered cheap heat to many cities around the world for decades. In Europe alone, district heating is already supplying 13% of the heat demand. By expanding district heating, it will be possible to improve the efficiency of the heat supply and also pave the way for 100% renewable energy.
When we wish in the future to get rid of fossil fuels and convert to renewable energy, then the heating and cooling sector will play a very important role. We will have to make it much more efficient and recycle some of the waste heat that we generate all around in society and use it to heat our buildings instead of burning natural gas and oil. That is what we call smart heating. But also we can use the heating sector to integrate more renewable energy in storage, heat storage, etc. This is what we call the future generation of district heating.
The work has already begun to convert Europe's energy and heating system to 100% renewable energy. The 4DH Research Network is bringing together the scientists, business leaders, and government officials required from across Europe to begin this transition. By doing so, it is possible to demonstrate how existing technology can help Europe to meet its CO2 targets in a cost-effective way. One example from the 4DH network is the Heat Roadmap Europe study, which describes how district heating will play a very important role during the low-carbon transition. By expanding district heating from its current level of 13% in Europe up to 50% by the year 2050, then it is possible to reduce our energy costs at the same time as we create more local jobs.
In order to identify feasible heat options for Europe, it's necessary to look at the very local conditions, identifying where we can make heat savings and use waste heat. In Heat Roadmap Europe, we combine this knowledge with overall energy system analysis. By doing so, we can redesign the European heating sector. The results are that we're able to enhance the European security of supply, reducing the imports of fossil fuels. We can reduce the risks of energy poverty, and at the same time we have a much cheaper heating supply for European citizens.
However, district heating is not a new phenomenon. In fact, district heating has been used worldwide for more than 100 years and has repeatedly adapted to changes in resources, technology and society.
The history of district heating is that the first generation was using steam in the pipes. It was introduced in USA in the end of 19th century. And this technology was challenged by European engineers in the 1920s. They chose to use water in the second generation. And the temperature was just above 100 degrees. But that technology was later challenged in the third generation by Scandinavian engineers that wanted to use temperatures below 100 degrees. And the driving force for this change has been that both heat supply and heat distribution becomes more efficient at lower temperatures. And all this technology generation is now challenged by the fourth generation that will be a fantastic efficiency in the future.
Today, 40% of the energy consumed in Europe is for heating. Most of this heat is provided by oil and gas that is burned in boilers located in each building. In the future, cities could buy their heat from a public grid, just like electricity, by using open-source district heating systems. These networks will be able to integrate many different types of renewable energy and make it possible to collect vast amounts of waste heat.
Right now we're putting a lot of resources into trying to diversify our natural gas supply because we're really worried about security of supply in the future. But what we have found is instead of looking for new sources of natural gas, we can simply replace it with all of this excess heat that we currently throw away during electricity production. So we can take that excess heat that we currently throw away and use it to heat the buildings instead of buying natural gas and using those fossil fuels to heat the buildings.
Today, there is more heat wasted during electricity production in Europe than is required to heat all of the buildings in Europe. This waste heat currently disappears into the sea, rivers, and the atmosphere. With fourth-generation district heating, this waste heat can be collected from the power plants and delivered to the consumers, who can buy the heat as they need it. The same applies to industrial production. With proven technology, Europe's industries could collect enough waste heat to supply up to 50 million households. A typical example of waste heat recovery from industry is Aalborg's Portland cement factory in Denmark.
In Aalborg, almost 40% of the energy for district heating is surplus heat from the industry, as Aalborg Portland we see, and the waste incineration. In the future, we actually believe this figure to rise to even more than 50%, as we still recognize a huge potential for district heating from the industry. Furthermore, we actually plan to use cold artificial lakes along with groundwater for district cooling purposes in the city of Aalborg.
By collecting the vast quantities of waste heat with fourth-generation district heating, Europe could save all of the natural gas currently used for heating its buildings, which would save 30 to 50 billion euros on imported natural gas each year. A significant contribution to the phase-out of fossil fuels and the gradual transition to renewable energy sources. The waste heat collected in the district heating system can be delivered affordably to millions of people in the cities and suburbs. Many homes will be able to remove their oil or gas boiler and instead connect to the district heating system. This will provide the consumer with a more comfortable, on-demand heat supply that, in addition to the savings, will prepare the heating system to gradually become 100% renewable. This will significantly reduce the CO2 emissions into the atmosphere and enable the world to meet its CO2 targets. Fourth-generation district heating will improve the efficiency of the heat supply and result in significant savings. In addition, it is important that the consumption of heat by the end user is significantly reduced. This can be done by improving the requirements for new and existing buildings. New, modern, low-energy houses will be built with much lower energy consumption than before, and the fourth-generation district heating will be very suitable for these buildings. However, between now and 2050, the largest potential for heat savings is in existing buildings. Existing buildings can be converted to low-energy houses and save up to 50% of its heating consumption compared with today. This is possible using solutions that are already available on the market, which can improve the walls, ceilings, doors, and windows. The remaining heat demand can be supplied with high-efficiency district heating, which uses prefabricated piping with a high-quality insulation.
So always try to do as much as you can in reducing energy consumption in buildings. The only problem is it takes a long time to implement that in existing buildings because you have to do it when you renovate the buildings anyway. But when it takes a long time, of course, then it's important to get started. So get started doing something about the buildings and then make the adjustment for the heat supply system in parallel.
More low-energy houses will make it possible to lower the temperature in the district heating system from approximately 90 degrees Celsius to 50 degrees Celsius. A lower temperature will reduce the amount of heat that is lost in the network, and it will also be possible to collect even more waste heat from the power plants and industry. The potential savings from low-temperature heating can already be demonstrated in the city of Aarhus in Denmark. This city combines highly insulated twin pipes with very efficient heat exchangers and water heaters.
This is a substation for the fourth generation of district heating. The low-temperature district heating water enters here and goes into two functions. The first one is domestic hot water, which is provided by instantaneous heat exchanger and is connected here. The second one is the heating circuit. That could be floor heating or radiator heating. One important part is actually the control equipment. Modern and efficient equipment secures a high level of comfort and at the same time a low return temperature for the utility.
Fourth generation district heating is the key to big energy savings. But an efficient heating system can also balance and utilize renewable energy from other sectors, such as electricity and transport. This integrated approach is called Smart Energy System. The Smart Energy System will get most of its energy from wind, solar, wave and hydropower. Energy will primarily be created as electricity, but it will be used in other sectors using technologies such as heat pumps and electric vehicles. As more electricity is produced from renewable energy, the energy system will need to replace the fossil fuels we consume today with electricity instead. Large heat pumps can be used on the district heating network to produce heat, which can be stored in a steel tank beside a cogeneration plant or a large underground seasonal storage. This will connect renewable electricity production to thermal storage, which is far more efficient compared to electricity storage such as batteries. It is also a much cheaper storage solution, since heat storage costs about 100 to 1,000 times less than storing energy in batteries. Today, there is already a connection between wind power and heat storage in many Danish district heating networks. The combined heat and power plant, Studstrupsværket, also has a large electric boiler that supplements the heat produced for the district heating system. The electric boiler can use wind power to produce heat, and if there is too much heat production, then it can be stored for several days in the heat storage next to the plant.
That we can see here is two very large electric boilers, 2 times 40 megawatts, and approximately can that be district heating for 5,000 to 6,000 households. Why are we doing that? We have a lot of wind power in Denmark, and these two boilers can transform wind power to district heating and green district heating. This is important because we have the possibility now to deliver 100% CO2 neutral district heating to the customer in Aarhus.
The smart energy system will use biomass, such as manure, straw, wood, and waste in different ways when renewable electricity cannot be used directly. For example, gasification and biogas are crucial in the future, since they will also produce waste heat for district heating systems. The biogas produced will primarily be used in combined heat and power stations and in industry. Waste can also be used as a fuel. Some of the waste can be recycled or used for biogas production, but the rest can be burned in large incineration plants where the heat can be extracted for the local district heating network. It is estimated that approximately 100 million tons of waste could be used for heat today instead of putting it in Europe's landfills. Choosing the optimal products and design for a district heating network is crucial to keep the heat loss in the network at a minimum. District heating is distributed in pre-insulated pipe systems and has an expected service life of more than 50 years.
In Aalborg, the main focus is to minimize the heat loss from the pre-insulated pipes system to the lowest possible level. That requires high quality of the pre-insulated pipes and stable quality of the insulation. Their choice has been Logstar twin pipe in the highest insulation class and with the special feature that the insulation value will stay constant during the entire lifetime of the system of more than 50 years. The surveillance system and the high quality of the welded joints will secure a flawless operation and the long lifetime of the network.
Smart metering solutions are becoming more and more important. Transparency and monitoring of the distribution network are two significant factors in achieving high efficiency in the network. Frequent data enables monitoring of the energy performance of buildings, indicates potential areas of improvement, and allows for visualizing the consumption in each individual household.
This is our latest Camstrup smart meter. In Camstrup, we believe that intelligent metering solution will help to ensure a sustainable use of our energy resources, simply because you cannot optimize what you do not measure. And we believe that smart meters can be used to so much more than just billing. Frequent data provides the information you need to optimize your production and to run your distribution network closer to the limits. And finally, we believe in engaging the end users to help them understand the consequences of their energy behavior.
District heating is suitable in urban areas, but what about the buildings outside of the cities? Today, these buildings usually have an oil boiler, but in the smart energy system, these should be converted to individual heat pumps. This will improve the efficiency of the heating sector and integrate it with the electricity sector even more, again paving the way for a 100% renewable energy supply. Heat will also be supplied from renewable energy such as solar panels on the roofs of private homes or large commercial installations. These plants already represent a large part of the heat supply and will be expanded. In addition, more heat will be produced from geothermal installations, where the heat is extracted at high temperatures from the ground. Up to 25% of Europe's population live in cities close to geothermal heat. In the smart energy system, bioenergy and electricity will also be used in the transport sector by combining CO2 from the power plants with hydrogen produced from electrolysis. This will produce some new fuels in both liquid and gaseous forms, which can be used for cars, trucks, ships and aeroplanes. The waste heat from these processes can be collected in the district heating network, which means there will be an abundance of waste heat in the future also. Europe already has around 6,000 local district heating systems that supply heat to 60 million people. However, 140 million Europeans live in cities where there is already an existing district heating network. Therefore, the share of district heating can be increased simply by expanding the existing networks. In the Heat Roadmap Europe, researchers have identified the most suitable areas to begin developing both new and existing district heating networks.
In Heat Roadmap Europe, we have mapped heat demand across European towns and cities. Heat demand density is the most important parameter for the feasibility of district heating systems. We have delineated possible areas where we can develop district heating. We have calculated the necessary investment costs. We know the sources of district heating. We know the waste heat potentials. We know the renewable energy sources available in each location. And we can conclude that district heating is a feasible solution in many towns and cities across Europe.
By implementing heat savings, district heating and the smart energy system concept, it will be possible for Europe and the rest of the world to gradually eliminate fossil fuels. Fossil fuels will be replaced by local infrastructure, such as district heating pipes and production facilities, which will create more local jobs, save energy, and pave the way for a 100% renewable energy supply.
District heating is a win-win situation for Europe. First of all, when we compare the cost of district heating to the fuel we save, we can actually decrease the cost of heating Europe. But at the same time, we will also generate jobs, because instead of importing fossil fuels, we'll spend the jobs on workers who will do the construction work instead of burning all the fuel. And that will generate jobs and make it cheaper at the same time.
Europe can replace all of the gas it currently imports for heating in its buildings and replace it with local waste heat. Work has already begun to implement these changes and create an effective transition away from fossil fuels towards a society based on renewable energy. a necessary transition in regard to the climate, and a transition which will mean that we in Europe take responsibility for the production of the energy we consume. All in all, something which will contribute positively to the economy of consumers, businesses and industry, while improving the life and welfare of individual citizens, of society as a whole, and of future generations.